Hello and welcome to this video on a rather weighty subject. The new kilogram, which is a vastly improved version of the old kilogram. For those used to freedom units, a kilogram is 1000 grams or 2.2 pounds. It is a common measure for everyday items like flour, sugar, water, goods sold by weight such as meat, cheese, and so on. It is a universal measure in civilized society. As far as what a kilogram is, well, we have a direct definition of 1000 grams. To apply this in practice, there is a reference weight. That is the standard kilogram. The standard kilogram is a piece of cast platinum and iridium made in 1879. It is kept in a cylinder that is in turn kept in a triple-locked underground vault in Paris. There are 6 official copies of this reference weight. The original is also called the International Prototype of the Kilogram, or IPK. As you can imagine, with these 7 versions across the world, you have a easily referred to standard if it needs to be calibrated, and the copies are calibrated on a reasonably regular basis, every few years or thereabouts. This is also how you could physically confirm the accuracy of your measure of a kilogram, or at least countries could, 6 other countries. It's not really that accessible, is it? This is a physical check, and the idea of physically confirming the veracity of a kilogram has been contested for some time now. It does have some rather obvious flaws. For example, when you're using a physical reference, you can find that there's issues to do with very small changes with them over time. A very small scratch could take off a fraction of a gram, and now the reference kilogram is going to be very different to what it was before. There's also issues to do with wear and tear. The final and perhaps biggest problem is, what if this reference kilogram is ever lost? How do you create a new kilogram, or will they take one of the existing copies and elevate it to the official leading kilogram? This is what led to the new kilogram, something not reliant on a physical object, but instead a physical measure of the force and properties of the reference kilogram. The idea here is, rather than rely on the physical mass of 1 kilogram, the new reference kilogram is going to use not just the unit of mass, but the associated electrical forces that come from this. That is, if you take a kibble balance, which is a rather fancy device used to measure the forces at play in a mass, you can measure how much energy, specifically electrical energy in the form of force, is needed to counteract what is supposed to be 1 kilogram of weight. This is an indirect comparison of the two, but where you have a mechanical balance or scale, you can get an equivalent electrical power measurement. So you can, in theory at least, draw a apples to apples comparison between the two. The way it's set up is that they place the reference sample in there and they measure the downward pull of gravity on this. The way they do that is that they apply an upward electromagnetic force. This is done by placing the reference weight in a coil, passing a current through that coil, and causing it to effectively resist gravity. By getting it to rise a certain measure, they can get a measure of how much energy is needed. And this is the measure of electromagnetic force. That would be the easiest way to measure the equivalent amount of a reference mass. You're no longer stuck with the platinum and iridium original, nor the 6 copies of it. This isn't a crazy new idea. The basics, in fact, are very old. The challenge, as with just about anything in science, was not the idea, it was getting consensus on the idea. Getting enough people, particularly those responsible for the System International, to agree on a definition and then, worse yet, a new definition, takes a long time. Not only do you need to convince people, but then you need to get a very reliable, very consistent measure. And in order for the new kilogram to be accepted, they had to have an error rate or a variation rate of 30 parts per a billion. This is the decimal place followed by 7 zeros and then a 3. That is a tiny rate of difference between measurements. Despite all of these barriers and the general reticence from changing from the old system to a new system, as demonstrated by the continued use of freedom units, the new kilogram's mass corresponds to 1.47555214 by 10 to the 40 photons. Yeah, it's a weird way of measuring it, but this was done with cesium, 133 atoms. And the importance of this is that it's also the same kind of frequency and measurement used in atomic clocks. This means that you can now, to some extent, correspond the measure of a kilogram to time as well, using atomic clocks. The decision is a few years old now, having been effectively endorsed in November of 2018, so we're not talking about brand new news, but it's news that may not have been brought to your attention at the time. At that time, the International Bureau of Weights and Measurement voted to revise the definition under the System International of what is a kilogram. And the new definition reads, the kilogram, the ampere or electric current, the Kelvin temperature, and the mole, very small entities such as atoms. Admittedly, only one of these is particularly important, the kilogram, to this video at least, but it's worth being aware of. It does happen every now and then that definitions get changed. Ultimately, the new kilogram will change almost nothing for most people. You're going to have exactly the same mass of anything you're buying per kilogram. The kilogram itself has not really changed in that respect. It's only in very narrow applications such as physics that this would matter, or other obscure niches. That's because these are areas where the tiniest measurements can be taken, and you will see the kind of narrow, refined, and accurate results required to get the new kilogram defined being demonstrated. And that's the difference here. It's a technically new thing that for most people will never matter until you see the fruits of this new definition being played out in real research. Thank you for watching this video. If you have found it interesting, consider liking, sharing, and subscribing. Please post any comments, questions, or suggestions you have below.